Okay, so when you're writing code, comparing values is, well, it's just fundamental, isn't it?
Absolutely essential every day.
But, in JavaScript, figuring out if two things are actually equal isn't always super straightforward.
Yeah, that's a
Mm.
common tripping point. There are layers to it.
Exactly. We've basically got two main ways to check equality, plus this whole other concept of how values act in like a true-false situation.
Right, the truthy and falsy stuff.
So today, let's really get into those equality operators, the different equal signs, and what truthy and falsy actually mean.
Sounds good. The goal really is to understand why JavaScript behaves this way and how it affects the code you write day to day.
It's kind of fascinating that there are two ways to check if things are the same. Let's start with the first one, the strict equality.
Yep, the triple equals. That's the one most people recommend using by default and for good reason.
Because it's stricter, it doesn't play guessing games.
Precisely. The key thing about TIA is that it checks for equality without doing any automatic type conversions. So if the types of the two things you're comparing are different, it just says false. End of story.
So it's checking value and type have to match, both.
Exactly. Value and type. That's what gives it predictability. 1 equal 1 is true, obviously,
Okay.
but 1 equal 1 number 1 versus string 1 that's false because the types are different.
Got it. Makes sense.
And the strictness applies everywhere. Null equals undefined.
Yeah.
Also false. And it's really important when you compare objects or arrays.
Oh, yeah. How so?
Well, two separate objects, even if they look identical inside, like a 1, 1, 1, that's going to be false.
Right, because they're different objects in memory, different identities.
Exactly. They have to be the exact same object instance for it to doubly be true.
Yeah.
It avoids confusion.
That predictability really does sound like the way to go to avoid nasty surprises. Okay, so then there's the other one, the double equals. This one feels a bit more
Loose.
loose is a good word. Or abstract equality, that's the operator. And unlike strict equality, this one will try to convert the types before comparing if they're different. Okay, so it tries to be helpful maybe by converting types?
It tries. But the rules it follows for this type coercion can get pretty complicated. And honestly, sometimes they feel a bit weird.
Right, so it might turn a string 1 into the number 1 if you're comparing 1 equals 1 and then say true.
Yep, that's a classic example. 1 equals 1 is true, but it goes further.
How much further?
Well, things like null, undefined, actually evaluate to true.
Oh, okay. Unlike with triple equals.
Right, and 0 equals false is true. Even an empty string equals false is true.
Whoa, okay. I can see how that could lead to some head-scratching moments. You might not expect an empty string to equal false.
Exactly. Those implicit conversions are where the bugs hide. You think you're comparing one thing, but JavaScript converted it first, and you get an unexpected result.
So the complexity and the potential for, well, surprise, that's the main argument for sticking with most of the time.
Absolutely. Using just sidesteps that whole complex system of coercion rules that equals uses, you get a clear, explicit comparison. Same value, same type, yes or no. Much simpler to reason about.
Okay, that makes a lot of sense. Now, related to this, but slightly different, is how values behave when you just need a Boolean, like in an if statement.
Ah, yes. Truthy and falsy. Crucial concept.
Yeah, tell us about that.
So whenever JavaScript expects a Boolean value, like inside if or while, but it gets something else, like a number or a string, it implicitly converts that value to either true or false.
Right. And some specific values always become false.
Exactly. There's a defined list of falsy values. Everything else automatically becomes truthy.
And we just need to know that short list of falsy ones.
Pretty much the main falsy values are false itself, obviously. The number 0.
Including -0?
Yep, 0 and negative 0. Then the empty string. Also, null, undefined, and nan. Not a number.
So just those 6. False, 0, null, undefined, nan.
That's the core list, yes.
Yeah.
If you have a variable holding any of those, and you use it in a condition like if my var, the condition will be false.
Okay, so if 0 doesn't run, if null doesn't run, that's super useful for checking if a variable actually has a meaningful value.
Exactly. It's a common pattern. These falsy values often mean empty or not set or 0.
And absolutely everything else is truthy.
Everything else. And this trips people up sometimes. An empty array, truthy.
Oh, okay.
An empty object, also truthy. The string false,
Yeah.
truthy. A string with just a space, empty, truthy.
Wow, so checking if an array is empty isn't as simple as my array.
Correct. Because an empty array is truthy, that condition would pass. You'd need to check its length property instead, like
Wow.
if my array.length 0.
Ah, okay, so knowing that list of falsy values is key, because everything else just counts as true in a Boolean context.
Precisely. It governs how your if statements and loops behave, another subtle but vital part of the language.
So wrapping this up then, we've looked at JavaScript's two equality modes. Strict, which is predictable because it demands same type, same value.
And loose, which does type coercion that can sometimes be, well, tricky.
And we also covered truthy and falsy values, that short list of things like 0, null, undefined that act as false in conditions.
Right. And the big takeaway, stick with strict equality whenever you can. It makes your code much easier to predict and debug. You avoid the whole coercion minefield.
Definitely seems like the safer path for reliable code.
For sure.
It really makes you think, though. If basic things like checking equality or truthiness have these, layers and specific rules, what other assumptions might we be making about how our code actually works under the surface?
That's a great question. Always worth questioning those assumptions as you learn more. Food for thought.